Lovely and slightly damp Linlithgow Berg halls. Our opening session today will feature a consideration involving everyone here of the connectivities and geographies that define our understanding of scientific knowledge and scientific communities. So what we have, by very hastily formed consensus, agreed to do is an interactive presentation and discussion that will involve quite a lot of hands-on work from you. This will work best if you're at a table with 3 or more people. So if you are not at a table with 3 or more people, please arrange yourself accordingly now while we're getting settled. And what we're going to do is, for each of our 3 lovely people in the seats over here, each has been asked to provide one uncaptioned image, and our opening exercise will be sequentially to ask everyone at your tables to come up with a 1-sentence caption for that image, and then we're just going to whip around very quickly and hear all of those sentences for each one. Then we will discuss that image and then move on to the next one. And also, when you're sharing your caption, if there are any other observations about the image that you want to make, do throw those in as well. So our first image is this one here. So please collaborate with your tables, agree on a 1-sentence caption, and then we'll hear all of your captions and we'll go from there. Of the book and of bibliography and other mind this image.
Thank you, Michael. And thank you for the guesses. Security, defense, that was actually a really interesting one to think about. I'll tell you what this is shortly. In 1945, George Polya, then a full professor at Leland Stanford Junior University, submitted a series of interlinked Montaigne-style philosophical essays in English to Princeton University Press. Some thoughtful editor must have told him that philosophical essays don't sell. What about a textbook? The manuscript was cut down, literary excerpts removed, and it was remade into one of the strangest, most remembered books about elementary reasoning and mathematics of the 20th century. Comprised of approximately 70% dictionary of heuristic methods covering such things as the use of aphorisms in reasoning, as well as mathematical induction. About 10% imaginary dialogue in a Robert Boyle style, and another 20% of preliminary material. It was reprinted twice in the first year and quickly reached over 10,000 copies in English and was translated the first year into several languages. And within the first 15 years, we have an accounting of George Polya of every language in which it was translated to. This interests me because the book began in the 1920s as a lecture series in German to teachers of elementary mathematics on how to teach mathematics, was presented in French shortly after that, and then brought to the United States at Stanford University, where it was taught in English and became this ragtag assemblage of essays that was cut down, published into the short How to Solve It, and then published into 3 more books because it was a massive undertaking he had done. He's accounting here on his vitae about 15 years later of all the different languages his work has been translated into. And there's a lot to say here, and the different languages are really interesting. There's something about writing a book in 2 or 3 or even 4 languages simultaneously, which makes it easy to translate. But the thing I'll draw you to right now as an emblem of our collaboration is in the upper right, you see the in-papers of the English edition, the first one, which gives a kind of schematic. This was the aide-memoire he put on the chalkboard for the elementary school teachers. And here below, you have what he calls the Yugoslav translation, which more appropriately, my colleague Jan has helped me understand, would be called Croatian to us, because there's a distinction there politically that he wasn't making. And so I'm very interested in the question of why is it so heavily translated? What is his agency in making this a global textbook of mathematics, or is it a global textbook of philosophy, or is it something else entirely? So security is interesting, right? Because this is, in some ways, he's defending his position, I guess. Although at this point he had published over 300 papers in mathematics, so I'm not actually sure he needed to figure out how many translations he had.
Wonderful. Thank you, JP. Polite claps. So our second image, which we'll do the same exercise for, is this one here. So again, take a few minutes, decide on your 1 sentence, and then we'll go around and hear what you've seen.
Yeah, somehow. So, okay, so it's good, because it's weird molecular biology. Actually, it's DNA repair. And so what this map shows is that the pioneers in DNA repair field, they started in nuclear centers, like nuclear research centers. Afterward, they were paid to send radiation on cells, and they were considered as weirdos by the regular molecular biologists who were doing like phage research or this type of more classical molecular biology. And so here you can see just taking the pioneers, so the one who, so it was a bit like using bibliometric data to do it. So the one who have published 10 papers with the keyword DNA repair during the first period of this specialty, and what were their institutions. And so if they have moved from an institution to another during this first stage, you can see that the color of the link changed. So the black edges, they are the one going from their previous institution to their future institutions, and the gray edges, they are the one going to their previous institution to future institutions. So you have movements on this graph, and what you can see is you have not everything is connected, but at the center of the image is the American network, let's say. It shows that it has started in the US, if we use the bibliometric data, because it could be contested. And so, yeah, and also the interesting thing maybe is, for instance, the black star at the middle, it's Oak Ridge Laboratory, so it's one of the nuclear research laboratory of post-war America. And so they all moved from this laboratory after some time, because this laboratory stopped funding this type of basic research, because at the end they have discovered that DNA can repair itself, and then they were more interested in working on this, and not, so that's it. I have some image more, so maybe as you prefer. We can...
so yes, we'll do the quick version of the images.
Okay. So I wanted to tell a little bit more about this. So this is the map of the community. So where they first started, this is red dots, and where they have been, when they have activities in DNA repair in like the contemporary period, it's blue dots. So you can see a kind of evolution here. And so this is old works, because as you can see, it is dated now. And more recent work I'm working on is this type of map. So maybe very quickly, if you look at the places, they are not the same somehow, but if you can maybe identify which could be the specialty which is here, represented. Huh? Yeah, so you are cheating. So what is Oban doing for? Well, so here you have cities that most of them, they are by the sea and they do marine science. And here is the collaboration network around the topic of Ectocarpus, which is a seaweed. And so here it's all the papers about Ectocarpus that are co-authored from different places in the world. So this is what I like with this map. They are just changing a bit the hierarchy of the that we have in mind. So here is the more scientific one. So this is the same but more complete and with a legend and so on. So, and then you can see it's Ectocarpus. And so finally what is connecting the two cases is maybe genomics, because in the Ectocarpus field, Ectocarpus has become a model organism, and so its genome has been how do you say that? Sequenced, thank you. This genome has been sequenced, and this work was a collaborative work, of course, and it has been, mainly done from Roscoff, which is in France, in Brittany, in this building, which is the genomic building. And so Roscoff is one of the, maybe the most important marine station in France, and I've been doing some field work there for some time. And so they do this genomic work, and recently they have also used CRISPR-Cas9 to create a mutant, an Ectocarpus mutant. And this work has been done in collaboration with Oban. So this is why I'm here currently, because I work with Nikki on these marine stations and how they are connected. And to finish, so it's now almost the end, when we want to look at the history of these connections, because you could assume that these marine stations, they have links for a long time because they have been created at the end of the 19th century. So, but the problem is when you use bibliometric data to map these connections, it looks like, so here it's all the European links of Vrhovski, but it's represented with the time when they have started. And so if there is a publication co-authored with one of these places, there is a dot. And so here I've just selected the European cities. And so it feels like they have only started to have international connection in the 70s, which is completely untrue, as the stations exist in the late 90s. And when there has been this movement of marine station, they have all been created a bit at the same time in Europe. And so we can imagine that they were like built on the same type of model, and people were moving from one to one and having like connection to each other and writing letters to each other or visiting each other. So we can't see this here. So this is why we have started to work with Nikki at going back in time and using like this more traditional data. That, for instance, here it's from the Granton station, which is the ancestor of the Oban station. So I leave you with this, I think.
Wonderful. So thank you, Marion. Okay, here is our last image that requires a caption. Suggested by Jan Vrhovski, a sinologist and historian of logic and philosophy, who will now explain what he had in mind.
Yeah, thank you very much for your responses. You were, of course, all right about the content of the picture. Now, it's complicated for me to introduce to you what I was thinking about this picture, because this is obviously a community of people. And my job as a historian of mathematics is to say the most about the community of people as possible. Now, as you all gravitated towards a certain set of answers, it shows that you share a common cultural sphere or perception or things in everyday life which influence how you see stuff. But we are speaking about 1930s, and my job is to do some detective work to see how this picture is not only a picture of a community. It's not only a picture of 200 people with 3 children. It's much more. It is a representative image of an international sphere of people, of many such pictures, which behave and interact with each other in a certain way. And my job is to decipher how this picture is not just a picture of a community, but something which tells me a lot about the world in which this picture was taken in. And of course, they're all male. Some of them are really grumpy because they're mathematicians. They're arranged in a certain order. There are also women, but you haven't, they're really like hiding. And they're all mostly Anglo-American, of Anglo-American descent. There are a few exceptions, of course, because 1930s was already time when people started migrating from Europe to the US, not in such numbers as during the Second World War. But this is a picture of an emerging society. It is a picture of a past, of an established past, of an established disciplinary past, which is a social past. And at the same time, it is much more, because we can also see the children. It is a reminder that they were actually living people, that they had a life, and that we shouldn't just reduce them to communities of people who do just mathematics and that's it, although this may be true for mathematicians. So yeah, these were my thoughts about this concrete picture. But my concerns are with other pictures, with pictures we don't see, with pictures which don't emerge in international mathematics so far. Pictures of Chinese mathematicians, well, there are many pictures of Chinese mathematicians, but they do not figure well in our Western historiography of mathematics yet. Pictures of Indian mathematicians, which need a lot of attention, they earn they've earned their right to be in the huge picture, pictures of many different particular communities in the world. I've also got another picture, but
Yes,
what's your plan?
Just describe this. We'll not do the caption, but let's just see the picture.
Oh, yeah, and this is, for me, this symbolizes mathematics as such. Do you recognize the device? The Chinese people are saying, yes, yes.
Say some words.
Yeah. Abacus, yeah. But now imagine this abacus allows you to make mathematical operations, right? To calculate stuff. Can you use it? Would you be able to use it? One person would be able to use it. Why? Because you were taught how to use it. For you it's simple, but I would be staggered. I wouldn't know how to start. I wouldn't know how to read the results. But it's still mathematics, it's still universal knowledge. It's still concrete, it still works. So this tells me a lot about history of mathematics. So in order to know how to use an abacus of this kind, you would have to grow up in a certain cultural environment. But mathematics at the same time is a universal thing. This for me is a symbol of what we are doing in Michael's project. Yeah.
So we now have a little bit of time for discussion. What we thought we would do is start with the panelists asking questions and responding to each other, and then we'll open up back up to the tables here. While you are thinking of your own questions, the other exercise that we wanted to ask you all to do is I'll wander around with some post-it notes, and we want. Do you want to just explain? Yeah.
If you like, yeah. Yeah, there is an exercise. So there are like color pencil and pens here that you can use. And if it's okay for you, if by table you can collect the names of the cities plus country where you have done your PhD and then have been appointed in your life. So you will have a group of cities per table that I will collect at the end. And so we could do like a map at the end of the day with all the places. And when there are people who have been in the same places, the size of the circle will be bigger, so we could have an idea of the scope of the present community today. So if you can just do this list of cities that you have been, like where you have done your PhD and when you have been appointed afterward, and maybe where you have been visited, because for me it would be like Toulouse, where I did my PhD, then Paris, where I'm currently appointed, and maybe Edinburgh as I'm visiting, or I don't know. You can make some pick as you wish. And then also, if some of you have an artisty fiber, they can also draw some, I don't know, networks or maps if they want. But then the most important thing is just you collect the cities, and cities plus country, which is easier to map. Thank you.
And then we'll have a prize at the end with the reveal of the image. Just grab, yeah. Okay, so I'm just going to hand the microphone back to the panel, and then you can ask questions of each other.
To bring us back to the topic at hand, the connection I noticed, and actually I think about both of your talks in this respect, is what is a global connection? What is a geographic connection, right? We have kind of three different models. We have examples of collaboration in labs built in multiple spaces and people going out to different places. Does that mean they share a common culture? Does that mean they don't share a common culture? Does that mean there's a real connection and a real understanding, or is it adversarial? In the case of translation, I always think about, is it bidirectional or is it unidirectional? Is this a transmission of knowledge into the subjected language of the other? I think of John Eliot's translation of logic into Algonquin in the New World, whose purpose was to teach the natives to believe in Christ because you had to learn about Aristotle to do that for some reason. And is that bidirectional or is that one directional? And I think about Jan's point, which is thinking about these hidden connections, the hidden tailors, but the hidden wives and children and associates that exist within this. And I think one of the things that this team underscores is the question that we often take connection for granted. Having lived in two cities, in fact, you're experiencing it now. I experienced it, right? What counts as a city that's an influence on your map? A 1-month fellowship, 4 months, 10 years? What if you started a PhD but left it? Does that count? Do you have to get a degree? What if you have a friend who's from there and you talk to them a lot? Yeah, well, and it comes to the central problem of all of this research, which is connection is strange. We want it to be simple. We want it to be clear. We want this is this, but in fact, it varies widely. And so I'll make that as an initial observation with the hopes that you guys can riff on that. Does anyone want to take up connection? Or maybe the audience has an idea of the idea of connection. Like how did you define connection for making your list of cities? Who has the most tenuous connection to a city? Should we have put Linlithgow? Why is that funny? Is this not a city? Is it actually not a city? Is it not a city? It's a town. It's a town. Okay. Okay. Who put Edinburgh? Anyone not put Edinburgh? Why? Some of us have only been here. I've only been here since November. I have more connections to cities I didn't list. Why is this a city that is included on the connection? To what degree is this a performative, rhetorical stance, right? The school of, the place of, the culture of, and to what degree is it an actual transmission of ideas? And I think that's something that we all struggle with, is how to unpack this and how to work on it. That's my comment. I don't know if you guys have more.
Okay, maybe what I think about your talks, I was interested by this idea that what we don't see on these pictures and maps. As you were saying, Jan, that these mathematicians, they were the American, and we can't really see where are the Indians and where are the... And this is also in the maps I have worked on, like for instance the DNA repair maps, the first one where you were supposed to guess. I think this map was really good to also show what was absent from it, because the America was central, and then it was very interesting to discover that a lot was missing. And so it was both a map which was telling in terms of what was visible in the databases, and so then you could do all very much a work which would be trying to discover what is not present and why it's not present on the map. So this is something I think we have in common, that trying to understand this. And what I liked about your first image is that there is a connection between what is visible now in this bibliometric database, because it's in English, and so we can see more of what is produced in English, and what you were showing is something about language in science. And language in science is quite important, and we don't maybe discuss it enough as something which could help us to understand how ideas connect and how we build connection to each other. So, yeah, this is my...
It's a good example of this linguistic element that connects this comment to... it's a good example of this linguistic element that connects this comment to what Jan raised, which is historians of biology know that in the Stalin years, especially, the field of radiation biology is where all of the evolutionary biologists in the Soviet Union retreated during the Lysenko era. And this would expect one to find then nuclear studies of DNA and radiation and biology to be a major hub from a Soviet perspective in the chart that you showed, but instead one sees just one lonely Soviet scientist, and that has a connection certainly to another Stalin-era policy which required publication in the Russian language and the Russian language only for work that was going to be endorsed by the Soviet Academy of Sciences. And so here you have a very clear example where you have a kind of intellectual connectivity. This was the field in the Soviet Union that was the most connected to the West in intellectual and conceptual terms, but because of a language policy appears very disconnected in the graph of publications. And I'll pass it to Jan.
Because I may know more about language policies. Well, it's really hard to say something positive about, like positive in sense of positive knowledge about intercultural connectivities and connections and overlappings and exchange. One reason for that is language, of course, because we kind of seem to be like really hesitant in recognizing that languages are fundamentally different. And then that to learn a language means to learn much more than just a bunch of words and how they connect and how you, by means of like universal grammar, create meaning. Languages are much more. They're reflective of our past, of our cultural basis, of how we think, and most importantly, how implications are made. And one thing about maps and images is that, well, what are the implications of maps? What do maps mean? Why do we need maps to establish more objective knowledge? Because they say something more than not having maps? In methodological sense, doing international mathematics and international science now, including language and culture, also means an apophatic endeavor. To be able to say methodologically what we cannot say and where we should stop in implications. The reason why we have all-white Anglo-Saxon mathematics or historiography of mathematics had a lot to do with implications in the past. Implications of cultural supremacy, implications of being able to wage war and stuff like that. And it is all embedded in things we do now, still, unfortunately. Well, there are also positive aspects to exchanges between languages, between different cultures. Namely that sometimes we tend to think that the boundaries were much deeper, but on the other hand, when you delve deeply into the histories of communities of personal exchange, you see that actually people tend to always strive to overcome these boundaries. So there are always links across continents, across cultures. I think that people here in this hall are a good example because we are an international community. So sorry for being a little bit philosophical.
Yes, Phil, we're not so afraid of philosophy here. There's a link between that and this question of translation and geography that I think will be drawn out by a question that Robin had during the interval. Do you want to make that observation for everyone?
Yeah, I was quite intrigued by the map you put up because it was very revealing. For example, it had England as a destination rather than UK, and actually here that caused a sharp intake of breath, but not in France perhaps. It was clearly francophonic, but there were interesting things that some things needed explanation and some things didn't need explanation. Actually, when I filled in my map here, I realised I'd put Cambridge and Birmingham, and I had to then add UK, but I've never done that before because I take it for granted that everybody knows that Cambridge and Birmingham both in the UK, but some others might have a different view about where those are located. So the question is, which places are known and intimate to us and which need subdivision? Like USSR, the whole block, Hic sunt Leonis, yeah? That didn't need distinction, but there were different places in America. And Ontario was there, and Canada. So my guess was it was written by probably a Quebecois, or at least somebody whose worldview was informed, even if they might live in Paris, was informed by a Montreal view of the world. It wasn't a view from nowhere.
I think the reason for England being on the map, it's more because of how the databases are built, because they do this distinction. When you use the affiliations from, I think, Rainbow Science and Scopus, they consider Wales, Scotland, England, they are countries. So they don't. The United Kingdom, if you want to have it, you have to rebuild it in this database, which is interesting. And also, then for the US, now it's, but you can easily have the states. So this is what they give you as information. And these databases, of course, they are really important in building what we know about the geography of science, because a lot of persons are using them, sometimes without knowing the biases. And I was thinking about this question of language that, for instance, so the Web of Science has been created by Eugene Garfield in the 70s. And his idea was to make the Web of Science, so it was not called the Web of Science at that time, but he wanted to create a universe where the science, there was no boundary between fields. So this is the idea of the citation index, that you can go from one text to the other, whatever the place it is published. And also the dream was that everything was in English, because for him there should be one language of communication. And so he was often very talkative about the fact that he didn't understand why there were still publications in other languages than English. So sometimes he had like some controversies with different people in France or Germany. And also there is one interesting piece where he just give his thought about the fact that he doesn't understand why, when Lenin was in power in USSR, why Lenin has not removed the Cyrillic alphabet, which was making it very much difficult to know what was published in Russia or USSR. So this is the type of thing I was thinking also about this.
Yeah, I was wondering also, like, some of the problematic aspects of like mapping, when you have like a diagrammatic thing, it appears flat, and then it appears to be like a representation of knowledge, but what it really is a temporal representation at a point in time of a particular knowledge set, and then, you know, what other maps are behind that map. And I think it kind of leading into kind of what you're hinting at was that maps aren't, I mean, I think maps to some extent are not like, don't evolve out of knowledge, like a curiosity, they evolve out of power. So they're colonial, you know, controls over land, and if you can map it, you can control it. And then sort of somehow related to that, I was thinking like language is a map, which I hadn't really thought about. But there's so, for instance, we might think of like mathematics being Anglo-Saxon, but then the common ideas, like algorithm is Arabic. The concept of zero comes from Indian mathematics. So like we're still living with like many different modernities, but then they seem to get shaped into like a European mapping. So I was just wondering, like, is there maps that could challenge that or somehow show that differently?
I'm going to make an observation while I move the microphone, which is that one thing that we've been thinking a lot about in our research group is the relationship between endogenous and exogenous products of mapping and charting. So we've seen in this presentation, these images, examples of both maps that are produced by scientists and mathematicians in the course of doing science and mathematics, and thinking about the distinction between using those as a form of historical evidence as opposed to maps and charts and network diagrams that we produce on our own as sort of derived data. I'm going to take this intervention from Jamie, and then I'm going to go back to the panel.
Yeah, I don't want to appear too mystical about this, but I want to raise a question. You mentioned that mathematics was a route to objectivity, and I'm just wondering, if you look at the history of maths, the reference to zero and to advances and to changes in maths, it raised the question to me, is maths, as we understand it now, completely what we like to think of it? I can imagine a world, a broader intelligence that has our maths as a sort of limiting, minor, erroneous set of beliefs. And I think that we should contemplate that possibility, especially if we're looking at STS.
So another really useful way into this problem of universalism that animates these presentations. JP.
Well, I'll take the map one first, because actually it's an insight that I was just thinking about. I didn't think about it until just now. This thing on the left, that's a map. So what you have across the top are 6 books, which is numbered, well, 3 books, 3, 4, 5, and 6, and 1, 2, and 4, which only have one translation, so they don't get a column. And you have an X for every language that it's gone into, but those languages correspond to a region, shared culture, more or less. The book corresponds to an idea. And part of what's interesting to me about this project is number 3 is how to solve it, the one I'm talking about. And this overwrites an incredible complexity, an absolutely mind-boggling complexity in its editorial history. There are two majorly different editions. Sometimes edition 1 is translated, sometimes edition 2. Sometimes the translation then takes on an independent life and has pieces added and removed. The editions are also separated into all these miniature little essays that kind of swirl around in the archive and don't have a clear placement. And so what I'm thinking about actually is this is a map from 1951-ish, drawn by Polya of his own work for purposes of security, probably, or just feeling good. And there's something about the context of who drew the map and what the map means and when that is and what their cultural context is and what things they may miss in the map, which I think is kind of insightful here. And I take spirit from the idea of map in mathematics, right? A map in mathematics has nothing to do with geography. A map is merely a series of correspondence between points. You have a set of things, you have a set of other things. Some of them have relationships and others don't. It's closer to what people commonly call a graph. So there's something interesting about like map as a visualization tool to kind of attempt to situate something in a moment, in a time, which I guess I wonder, I'll throw out there in case someone wants it, is mapping doomed to failure, right? Like is mapping a sort of like endless emptying of the bucket, a bailing of the canoe, which is sinking, which is it's impossible to have a universal unsituated knowledge? Question mark? I don't know.
I would just respond to two excellent questions, more challenges actually than questions. I fear I cannot answer your questions at all, but I can try by giving an analogy. In mathematics, it took us many centuries, if not even millennia, to move from Euclidean geometry to non-Euclidean geometry. It took us centuries to start focusing on elementary geometrics and start thinking about topologies, about spaces. Maps are something similar. Maps in intercultural research, in interdisciplinary research. The problem is how to use them. Are these reflections of spaces? Do we need compasses to use maps? And I think that we are trying to devise a compass here. We are trying to say that we can all have the same maps, but the question is how to use them and why to use them. Where do we want to go to? Where are we coming from? And what makes maps universal so that they can be shared amongst cultures? It doesn't mean that if I buy a map of London in Beijing, I will not be able to get around London. This is my analogy to what I think we are doing here. Your question was actually a good point. Mathematics is a tricky discipline to play with in historiographical sense because it's both seems to be universal, while at the same time, when you go back in time, it disintegrates into cultural spheres, into different beginnings, different environments, even different cultures of mathematics. So in this regard, it's good to pose a question, the Wittgensteinian question in a way, what is the alternative of mathematics? Because this leads us methodologically to another important question, which is how does mathematics relate to its origins? So we live in a world which we all share. So it's logical that we share mathematics. But at the same time, we don't share mathematics because the world, without us being connected, may appear different. So mapping a world requires a unified humanity, in a way, in intellectual history. If you get what I'm thinking about. So isolated culture, like China a few hundred years ago, had a really cultural specific mathematics. They didn't see any meanings in spreading their mathematics and trying to map the world beyond them, intellectually as well as geographically. But when the world started to come together in a global sense, like globalization, when we learned more about each other, then mathematics also behaved in the similar way. And yeah, This is my spiritual thought about what I don't know.
Okay, so thanks to your participation to this exercise this morning, now we know where are the different places you have been during your career, and so all of you, combining all your data, I could make this little interactive maps on this app, like I'm part of the developing team of this app, NetCity. So here you see the distribution at the world level of you, like the whole audience today. And here it's the country scale, and here it's the city scale, and you can map like this, zoom like this, and see that, of course, Edinburgh is the common dot for everyone. And then, because some of you did this as a more personal journey, I have also used the information with the links to connect the places a bit using what you have saying. So if it was like the name of the cities, they were on a common paper, I linked them together. So now we can analyze a bit the link between the places. So here is the country level analysis, and here the city, which is a bit more messy, but so you can zoom again. And finally, there are graphs with this, so it's the same data, but just put in a different ways. And so here is the country graph, and what I have some note about it, like there are 25 countries, which is not bad, right? 14 European countries, 5 from America, 4 from Asia, and 1 from Oceania. And so also you have the graph that you can play with, which is at the city level, which gives you some interesting structure, of course. Sometimes it's more or less obvious what you can see, or you can recognize a bit what it shows. Yeah, so I think this is it.